Hello everyone, welcome back. This is Mr. Tipton, and today we are interpreting constants of proportionality. Several lessons ago, we talked about how the constant of proportionality is what you multiply x by to get y, and how the constant of proportionality is also a rate of change. That's going to be very important to us today, that constant of proportionality is a rate, right? Miles per hour. Dollars per pound. It's a rate. Remember, unit rates can be written as labeled fractions with a denominator of 1, or like a kitty. We're going to need that today. Let's look at a real-world problem here. It says Peter uses the equation d is equal to 30t to find the distance in kilometers per hour traveled on his trip. And we're asked, what does the COP, the constant of proportionality, what does that represent? Well, let's go back to the equation first. D is equal to 30t. First of all, we know that constant of proportionality equations are in the form y equals k times x. Alright? Because it's a real-world problem, we can use things besides x and y, but it has the same meaning. Okay? In this equation, d stands for distance and t stands for time. So even though we've got a d and a t, it still means the same thing as y equals k times x. The constant of proportionality is still 30. We know that, but that's not what we're being asked. It's not what is the constant of proportionality, it's what does it represent. Because it's a rate of change, we want to know how things are changing in Peter's problem here. He's traveling 30 kilometers per hour. That's what the constant of proportionality represents. It represents 30 kilometers. And I'm going to have some trouble with my pen here because I've got a lot of writing on the screen. But I'm going to write it like a kitty. 30 kilometers per hour. That's what it represents. The time, the time is our number of hours, times our rate, which is 30, will tell us our distance. 30 times t gives us d. That's really pretty much it. The 30 is a rate, 30 kilometers per hour. Let's look at this on a graph. Maybe. Come on. There we go. What does the circled point represent? Feel free to pause and copy the graph down before you listen to me explain. Alright? But our x-axis we have hours, and on our y-axis we have kilometers. And our line, we've got our data, okay, 30 kilometers in 1 hour per hour. We got that from Peter on the last screen. And 60 kilometers in 2 hours and 90 kilometers in 3 hours. Right, our equation is d equals 30t, but that's not what we're asked. What does the circled point represent? Well, right here. It represents 60 kilometers traveled in 2 hours. That's it. That's all I need. I just want to make sure you know how to interpret a point on a graph. Okay? What's happening here, where the dot is right in between the 80 and the 100? The red one is 90 kilometers traveled in how long? 3 hours. Alright, so interpreting in a graph, really not too bad. Just use the labels, your x and y axis. 60 kilometers traveled in 2 hours. this is all the examples I have for you, because I think that's all you're going to need. But if you do have questions, write them down. We'll talk about them tomorrow. See you soon.